Okay, so let's look at this. So you have your implication, and on the left hand side of it, you have negation P. On the right hand side, you have another implication. Okay, so here you have negation and P, and on the other side, you have an implication again, and on either sides of the implication, you have P and Q. Okay, that is a parse tree. You have yeah, you have another set of examples in the slides as well. You don't have to upload the answers. Okay, just try them. Try to do them. Okay, now we are going to do something called checking the satisfiability of a given propositional formula. Then all of these are propositional formulas. Okay, so how we're going to check the satisfiability of a formula when it comes to a truth table. Okay, truth table when you assign truth values, how you can check whether this is satisfiable or not. So say you are given some kind of a formula. Let's take this itself. Okay, so this is your formula. Then make we assign truth values and stuff. Now we draw the table, and at the end of the table, at the ending column of the table, we get the final set of values for this. Yeah. So this is our truth table. Now, if all the values that we get for this, if all the values we get for each combination of truth values in this propositional formula are true, we say that this propositional formula is a tautology. It's a tautology. Again, it is never false, it's always true. Or we call this being valid. ඔක්කොම true නම් that is a tautology. ඊට පස්සේ ඕකේ අනිත් පැත්ත if ඔක්කොම are being false, if ඔක්කොම become false, we call that a contradiction. ඒකේ මොකක්වත් නැහැ අපිට true කියලා කියන්න පුළුවන් විදියක්, so it is going to be a contradiction. Right? ඊට පස්සේ say that all the evaluations give you false, but just one gives you a true value. එකම එක තැනක විතර එක වෙනවා. හරිද? එහෙම වුණොතින් we call that propositional formula to be a satisfiable propositional formula. ඒ කියන්නේ ඒක true වෙන එකක් හෝ තියෙනවා, ඒක නිසා ඒක අපිට satisfy කරන්න පුළුවන්. Satisfiable. හරිද? ඊට ඕකේ අනිත් පැත්ත ඔක්කොම එක වෙලා if there is a particular point where 1 becomes 0, ඔක්කට තැනක එයා බිඳුව වෙනවා නම් that we say is falsifiable. Meaning there is at least one case using which we can prove that this statement is false. In those cases, that particular formula is called a falsifiable formula. You need to see that if a formula is a tautology, if it is a tautology, it also becomes satisfiable. Yeah, because anyway ඔක්කොම එකයිනේ. It's anyway a tautology. At the same time, it is satisfiable because එකක් තියෙනවානේ true වෙන. So it will be satisfiable. In case if you are given a logic, a propositional formula, and asked to check the satisfiability or validity or falsifiability of this propositional formula, then මොකක් හරි උත්තර සෙට් එකක් මෙතනට එනවානේ. So if you get all ones, you need to say that this is a tautology. At the same time, you need to say this is satisfiable as well, right? එතකොට එකක් බිඳුව නැති, you say that this is falsifiable. If all are zeros, you say this is contradictive. If all are zeros and if just one is true, you say this is satisfiable. Right? So when you do the valuation කියලා කියන්නේ for each proposition you assign true or false values and you derive the set of values for the entire propositional formula at the end. When you do so, there are 4 cases in which this formula could be in. Okay. Now, if we come to the example in the same activity, question number 2. Question number 2 okay. Part A okay. Can you try to derive what it comes under out of the 4 categories? You will be able to see that each of the input combination gives you 1. Right? So this is going to be true in all the cases. Whatever. Therefore, this is going to be a tautology. At the same time, we say this is satisfiable. Because tautology, because all are true, satisfiable, and satisfiable because this proposition can be proven to be true in at least one case. Case as in input combination. Okay, right. So these are the 4 situations in which a formula could be in, a statement could be in. Okay. Then we come to the final part, which is okay, inference rules. You know about this already. Inference rules. Right? You have heard of modus ponens, tollens, this and that. Right. So apart from these inference rules, you know that you have what do you call associative law, De Morgan's law, and stuff like that. Okay, you have those laws; those are separate, which you know already, and then you have the inference rules. Let me inference rules set like that. So let's start from modus ponens. Okay, now what happens in modus ponens, as you know, you have a proposition P, then you have a propositional formula P implies Q. You are given that P implies Q is true. Right? Then you are given that P is true. First year, second year, we called these premises. Yeah. These are called premises. Premises means facts. අපිට දීලා තියෙන fact set එක තමයි මේ. Right? ඔය facts ටික පාවිච්චි කරලා තමයි අපි මොකක් හරි derivation එකක් කරන්නේ. හරිද? This will map with logic programming in the next semester. හරිද? ඒතර මේ ටික අපි ළඟ දැනටමත් තියෙනවා අපේ data store එකේ තියෙන facts ටික මේ ටික. Using that we will be deriving certain conclusions. එතකොට මේකෙන් එන conclusion එක අපිට කියනවා මොකද්ද Q. Okay, and we say that this conclusion is derived using Modus-Ponon's rule. So how does it come? How does it come? It comes like this. So if we draw the truth table, PQ innawa, we have P implies Q. Either. P implies Q එක අපිට එන්නේ මෙහෙමනේ. Okay. Now we have said that P implies Q is true. So P implies Q true when I'm another these places. Then they said that P is also true. If P is true, these are the two places that P is true. Okay. Now how do we derive on the conclusion? To get the conclusion, we have to check the combination of valuations where both the premises intersect. In මොනවාද මේ අපිට දීලා තියෙන premises දෙකම capture වෙන valuation එක තමයි අපි තෝරගන්න ඕනේ. In this case, okay, so both premises should be captured. හරිද? එතකොට මේකේ මේ looking at this, the place where both are colored is this. Yeah, so that says us that Q is true. That is how we say M is R, Q is true. Got it? That is how the Modus-Ponon's rule works. It has then මෙහෙම එකක් තියෙනවා. What is this? I don't think this was there before in previous subjects. So this ඊතලේ and E means this is a notation. Okay. Now back then when we used to solve used to do calculations, the mock එකක් දුන්නාට පස්සේ we use inference rules and we keep on solving. If you remember, we used to write in front Modus-Ponon's, using Modus-Ponon's, using Modus-Tollens. But from now onwards, we're not going to say that we used Modus-Ponon's. We're going to use this notation for Modus-Ponon's. Okay. So what does this mean? Ethale and E means E stands for elimination. Either. What do you mean by elimination? Now you had P and Q both in this premise, but you eliminated P and you are only taking Q. Either. Elimination. Okay. And why ethale? The arrow says what type of operation did you perform. Now you performed this on an implication. Yeah, so implication has an ethale. Therefore, you say you denote this as the what you call arrow and elimination. So that is the notation for Modus-Ponon's. Come to Modus-Tollens. Modus-Tollens doesn't have a notation like that. Okay, so what we use is empty. Let's do an example also and see. We use empty there. So what does Modus-Ponons say? Sorry, Modus-Tollens say? You have P implies Q. ඊට පස්සේ you have negation of P. මෙහෙම තිබුණාම they say that your derivation would be negation of Q. Negation of Q. You are given these two premises. Okay, these are the two premises you are given. Then you say that the derivation is that negation P is true. Conclusion. So let's see how that comes. Now let's go for another. You have PQ, P implies Q. Okay. Okay. P implies Q is true. So etuna is true. Then negation Q is true. Negation Q true කියන්නේ Q false නේ. ඒ කියන්නේ මේ දෙක. හරිද? So which is the case that captures all the three valuations? It's this case. All three are captured here. So that line says that P is false. That means negation P is true. And we are true here. Okay, so we need to take the set of combination of values for P and Q where the premises, all the premises we are being given are captured. Okay. ඊට පස්සේ you have double negation, you know what that is. එතන දිගට ආයි ඒකම එනවා. So that is denoted as this. And why do we use I here? This I stands for introduction. You introduce. දැන් මෙතනදී අපි තිබිච්ච මනුස්සයා එළියට ගත්තනේ, so that is an elimination. Here what we are doing is we are introducing a new way that you can write the same thing. Therefore we say introduction for I for introduction. Okay, and the double negation in front is to say, okay, that is the operation that we performed. Okay, then all right, you have a hypothetical syllogism. What this says is, in simple terms, what hypothetical syllogism says is that if you have a P implies Q and a Q implies R, then you can say that, okay, P implies R. Okay, this is simple. And how do you denote this? You say, again, what is the operation you performed? It's implication. And what did you do? You introduce something new. Yeah, that is why you use implication I. ඊට පස්සේ you have something called disjunctive syllogism. What happens here is you have POQ, and you are said that negation P is true. So this is a premise and this is a premise. Either POQ ke P false now, anyways Q has to be true, right? Therefore you say this is Q. So this doesn't have a notation. If you are going to use this, you say you are using disjunctive syllogism. ඊට පස්සේ you have something called addition. Addition කියලා කියන්නේ මොකද්ද? Then P කියලා කෙනෙක් ඉන්නවා නම් you just said that, okay, P is true. ඔච්චරයි. This is a premise. P no. P කියන්නේ P true කියන එක. So if it is the case, what you do is you go ahead, according to your context, you just add somebody into this. You add another guy into this. Does it make a difference? No, it doesn't. Why? Because anyways P is true, plus the operation doesn't make any difference of adding another one into the propositional formula. Yeah. If there's a case where you want this part as well in solving your problem, then you can go ahead and add something so that it doesn't make any difference. This is called addition. Okay. And this has a notation. What is the notation? What's the operation you do? It's O operation. And have you done an elimination or an introduction? You have done an introduction. So OI. Then you have something called simplification. So all of these are rules, inference rules, which you can use in your calculations. Okay. Then simplification can say you have P and Q as your premise. If that is the case, then you can remove one guy and say P is true. Or P true can pull on, you can say Q is true. So it depends on your context. Who do you need for your further calculations? You take that one out, right? Simplification. So the notation is, operation is and. Did you introduce or did you eliminate? You eliminated. That is a E. Whom did you keep? That make a pass. Underneath E, you get another number here. You write 1 or 2 or whatever. And what does that depend on? That depends on the one that you kept. You eliminated Q, but you kept P, right? Therefore, in this case, you say and E1, you kept P. In this case, you say operation is and, introduction or elimination, it's elimination. So E, whom did you keep? The second proposition, therefore and E2. So that's simplification. ඊට පස්සේ there's something called conjunction. So conjunction means if you are given that P is a premise, P true is a premise, Q true is a premise. If that is given, then what you can do, since P and Q both are true, you go ahead and connect them with an AND. Doesn't make a difference. Why? Because they are anyway true. Okay, the final propositional formula will also be true. So what is the notation for this? Operation is AND. You introduce something new and you have kept both P and Q. Therefore, you can write 1 and 2. If not, you can just say I and I because you have kept both of them. So that is that. And then finally, you have something called resolution. The resolution principle. This also is an inference rule, but in an upcoming lesson, in an upcoming discussion, we'll be talking about resolution principle in a deeper way. Okay. So this says that if you are given P and POQ is a premise, and if you are given that negation POQ is a premise, POQ premise එකක් POQ නෙමෙයි R negation POR premise එකක් කියලා තියෙනවා නම් what do you do is you add them together and you say that QOR is a it's a conclusion. Either මෙයා මෙතන true, මෙතන මෙයා false. Therefore, you can say that the addition of these two is going to be true. Okay. Right. So these are the inference rules. So you have modus ponens, tollens, this and this, and then you have syllogism, addition, simplification, these two. Okay. Yeah. Okay. Right. So now since we know the rules, let's go for an example. First of all, without going for a real, a case-based scenario, let's just take a direct example where you are given the premises rather, say you are given that P and Q and R.